Day 846 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3720, lexicographically smallest permutation greater than target. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given two strings S and target, both having length n consisting of lowercase English letters. Return the lexicographically smallest permutation of S that is strictly greater than target. If no permutation of S is lexicographically strictly greater than target, return an empty string. A string A is lexicographically stricter greater than a string B of the same length if in the first position where A and B differ, string A has a letter that appears later in the alphabet than the corresponding letter in B. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input S equals a string ABC, target equals a string BBA, the output is BCA. Explanation says the permutations of S in lexicographical order are ABC, ACB, BAC, BCA, CAB, and CBA. The lexicographically smallest permutation that is strictly greater than the target is BCA. So let's break this down one step further, right? We want all the permutations of this. A permutation is a rearrangement of all of the characters in a string. So boom, this is what we want. We want to find permutations of this. These right here are all of the permutations, right? These are all of the different ways we can rearrange these letters, right? So after we have all of the different ways we can arrange these letters, we want to find the lexicographically smallest permutation, right? And then it says a string is lexicographically greater than a string B of the same length if in the first position where A and B differ, the string has a letter that appears later in the alphabet than the corresponding letter in B. So in this case, we have our permutations right here. Boom. So we want to find the first place where the strings differ. So we can see that we have a B right here, right? So we have a B right here. We could skip the ABC and we could skip this ACB because we want to find one that is strictly greater, not strictly less than. So that's why we could get rid of these A's and B, these permutations that start with A, because that would be strictly less than as opposed to strictly greater, because that would go backwards in the alphabet and we're going forward. So we're going to look at all of the permutations that start with B, right, which are just these two. Now, once again, we found these two permutations. We want the one that is strictly greater from when the first position where the A and B differ. So right here, the first position, they're the same. This is a B, they all start with B, right? So now we're going to the second position. This is a B in the second position, this is an A in the second position, and this is a C in the second position. Now, once again, remember we want strictly greater. So if we go from B to A, we just went backwards in the alphabet. We want to go forward in the alphabet, right? Because it says has a letter that appears later in the alphabet. So right here on the first position where they differ with this B and then this A, that goes backwards in the alphabet. We want position that's later in the alphabet. So with this B, and C comes later than B, right? C comes after B in the alphabet. So that's how we know this is the permutation that we're looking for, and this is the permutation that we return. Now, just in case that didn't make sense, let's take a look at example 2. Example 2 is a little bit more tricky, but the same principles apply. So in example 2, we have an input S equals a string leet, target equals code. The output is a string EELT. It says the permutations of S in lexicographical order are these strings right here, right? So remember, we're trying to find permutations or rearrange this right here. All of the ways to rearrange this right here are given to us right here. Then we want the lexicographically smallest permutation that is greater than target then the target is EELT. Now, as you can see, boom, this doesn't start with the E, this doesn't start with the E, this doesn't start with the E. We won't get to E till all the way down here. So since E is all the way at the end, and we start with E's right here, we're gonna go with we could just go in alphabetical order since we wouldn't be going backwards, right? We're starting at E, and there would be no way for us to go backwards because it's either gonna be an E, L, or it's either gonna start with the E, L, or T, right? We got the E's, the strings that start with E's, we have the L's, or excuse me, the strings that start with L's, and we have the strings that start with T's. Now, the first place that they don't really differ, but we get to this E and we have all these strings right here that start with E, right? And these are already in alphabetical order. Now you notice this is the first one is our output because everything after this comes is greater than this right here, right? So this is the one lexicographically greater. I mean, this is the one we want because as you can see, these are the same, right? Boom. First place where they differ is the L and a T. But since we're already starting on E, now we can go in alphabetical order. We don't need to go with whichever one is later in the alphabet anymore because we already made it to, we're already in the E's, like we're already on the third character. So by the time we get to the third character in this example, then we could just go in alphabetical order. And since L comes before T, then it's lexicographically greater than this one. And then you might see this, you might say E comes before T, but then you have to remember this L in the second position. E comes before this L in the second position. So this string still wins, and that is why this is our output, EELT. So boom, y'all. Now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to create a constant, and we're just going to say let target chars equal, it's going to be an array, open up the parentheses, target.utf8. Boom. Then we're going to come underneath this and we're going to say let n equal, target chars dot count. Boom. Then required by the problem statement, we're going to say let Quinn O'Rath equal, open up the string s comma target. Then we're going to come underneath this and we're going to count how many times each letter appears in s. So we're going to declare a variable called frequencies and set that equal to an array, open up the parentheses, repeating, :0, comma, count, 26. Boom. Then we're going to come underneath this and we're going to say for char n Quino Wrath .0.utf8. We're going to open up the brackets and we're going to say frequencies, square bracket int, open up the parentheses, char minus 97, come outside of that, plus equals 1. Boom. Then we're going to store the part of the answer that currently matches the beginning of target by coming underneath this, and we're going to declare a variable called prefix, square bracket, uint 8, come outside of that, set that equal to a blank array. Boom. Then we're going to declare a variable called index and set that equal to 0. And then we're going to match as much as the target as possible using characters from S. So we're going to say while index is less than n, we'll open up the brackets and we'll say let letter index equal int, open up the parentheses, target chars, square bracket index, come outside of that, minus 97. Boom. Then we'll come underneath this, and we're going to say if frequencies, square bracket, letter index, come outside of that, equals 0, we'll open up the brackets and we'll break. Then we'll come underneath this, and we're going to say frequencies, square bracket, letter index, come outside of that, equals 0, we'll open up the brackets and we'll break. Then, oh, sorry y'all. We'll say, delete that because we had that right here. Sorry. We'll say frequencies, square bracket, letter index, come outside of that, and we'll decrement that by 1. Then we'll say prefix dot append, open up the parentheses, target chars, square bracket, index. Boom. Then we'll come underneath this and we'll say index plus equals 1. Now we're going to return the smallest available character that is strictly greater than the supplied character with a helper function. So we'll come underneath this and create that helper function by saying func smallest greater, func smallest greater character, open up the parentheses, than character, UINT 8. Come outside of that, going to return an integer that's optional, and we'll open up the brackets, and we're going to say let start equal int, open up the parentheses, character minus 97, come outside of that, plus 1. Boom. Then we're going to come underneath this, and we're going to use a guard statement. So we're going to say guard start is less than 26, else we'll open up the brackets and we'll return nil. Then we'll come underneath this and we'll say for letter index in start dot dot less than 26. We'll open up the brackets and we'll say if frequencies, square bracket, letter index is greater than 0. We'll open up the brackets and we'll return letter index. Come outside of that and we're going to return nil. Boom. Now we're going to build the completed answer by appending all remaining characters in sorted order. So we'll come underneath this and we'll say func build answer, open up the parentheses, we'll say prefix colon square bracket UINT 8, come outside of that, comma, greater letter index colon int, come outside of that, it's going to return a string. We'll open up the brackets, declare variable called answer, set that equal to prefix. We'll say answer dot append, open up the parentheses, UINT 8, open up the parentheses, greater letter index plus 97. Then we'll come underneath this and we'll say frequencies, square bracket, greater letter index minus equals 1. Then we'll come underneath this and we'll say for letter index in 0 dot dot less than 26. We're going to open up the brackets and we'll say while frequencies, square bracket, letter index, come outside of that, is greater than 0. We'll open up the brackets and we'll say answer dot append, open up the parentheses, UINT 8, open up some more parentheses, letter index plus 97. Then we'll come underneath this and we'll say frequencies, frequencies, square bracket, letter, index, come outside of that, minus equals 1. Boom. Still not done. Come underneath this right here and we're going to return. It's going to be a string, open up the parentheses, bytes, colon, answer, comma, encode, and colon, dot UTF-8. And then come outside of these parentheses, put a exclamation point. Now, if matching targets should stop early, try placing the smallest available character, then target index. So we'll come underneath this and we'll say if index is less than n, we'll open up the brackets and we'll say let greater letter index equal smallest greater character, open up the parentheses, then colon, target char square bracket index. Then we're going to come outside of this. We're going to open up the brackets and we're going to return build answer, open up the parentheses, prefix colon prefix comma greater than, greater letter index colon greater letter index. Boom. And then if we cannot become greater at the current position, we're going to move backwards through the matching prefix, and at each position we're going to restore its character and try replacing it with the smallest available larger character. So we come underneath this and we say while exclamation point prefix dot is empty. We're going to open up the brackets and we'll say let previous index equal prefix dot count minus 1. Then we're going to say let restored character equal prefix dot remove last, put a parentheses. Then we're going to say frequencies square bracket int, open up the parentheses, restore character minus 97, come outside of that and we'll say plus equals 1. Then we'll come underneath this and we'll say if let greater letter index equals smallest greater character, open up the parentheses, then colon, target chars, square bracket, previous index. Then we'll come outside of this. We'll open up the brackets. And we're going to say return build answer, open up the parentheses, prefix colon prefix comma greater letter index colon greater letter index. Then if no permutation of S is strictly greater than target, then we could come all the way down here and we could just return a blank string, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it, and we got our first error. So let's see. Okay, y'all, I think I found it. I think this needs to be an if, an if let, not a let. Let's see if that fixes it. Okay, and then we got another restore character that should be restored with a D. So let's run that again, see if that fixes it. It's accepted, y'all. So let's go ahead and submit it and make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom of the middle. And this is the bottom of the middle. And then this is the rest of the code, y'all. So yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.